So with 8.5, this is day 1. So the assignment is just 1 through 16, just the front side of this. So make sure you have your calculators ready to go. We're going to be doing something called the change of base formula, which means this. If you have log base b of a, this is the same thing as log of a over log of b. So here the base is b. Here I'm using a calculator, so I'm using log base 10, because in your calculator, with the log button, all right, it's just going to come up base 10 no matter what, depending on your calculator. So these are calculator problems, but you should be able to get decent answers for them. So here, this is the same thing as typing into your calculator, log 125 over log 5. Now, if you type log 125 into your calculator, hit enter, it's going to be a decimal. That's fine. But then if you divide that by log 5, you should end up with 3. Just 3. So double check your calculator, make sure you know what you're doing. If you don't know what you're doing with your calculator, then you need to watch one of my calculator videos that I've posted under material in classroom. This is the same thing as log of 343 over log of 7. And this one you should also get 3, a whole number 3 there. Now, they're not always going to be whole numbers, but these are, and that's okay. Now, it is possible to get negative numbers. So this would be like saying log of 1/8, tricky one to plug into your calculator, over log of 2. So instead of base 2, we have log base 10 of 1/8, and then over log base 10 of 2. And so this one should be negative 3. And then for the last example here, which it's always 3 on this one, but anyway, it'd be the same thing as saying log of 64 over log of 4. You should get 3 for that as well. So you see this, you're converting into that, plugging this into your calculator, and getting that. Okay, now you could try a real easy one. If you just do log of 100, plug that in correctly, you should get 2, because 10 squared is equal to 100. So that's why you get 2 there. You need that review. Now, for these next 4, you're going to be using your calculator, all right? You have to use your calculator, because even in the directions, it says use your calculator to approximate each to the nearest thousandths. Now, thousandths is tenths, hundredths, thousandths. So 3 decimal places is what it's saying here. Now, this one, since it is log base 10, all right, you can just plug that one straight into your calculator. Hit log 30, enter, and you should get approximately, I'll put the little approximate signs here, 1.477. That should be what every calculator gets out of it, okay, when you round correctly. Now, number 6, when you plug that into your calculator, you're going to plug in log 4.19 over log of 2. When you do that, ladies and gentlemen, you should end up with approximately 2.067. Once again, if you're not able to get these answers, if you're not getting them right, you need to figure out how to use your calculator by watching one of the videos or messaging me, or maybe even like looking it up online if you want. That's up to you. But you're going to do the exact same thing with number 7 and 8. So number 8, for instance, that'll be log of 3.4 over log of 2. And for that one, you should end up with 1.766. Now, when we get into solving, hang on. When we get into solving these, all right, things are going to be a little bit weird. All right, we're trying to get the variable by itself. So let me start off with number 9. When you have the base with the variable by itself, that's when you're going to do something called take log of both sides. This is what that looks like. Log of 18 to the k equals log of 26.3. All right, now I'm going to use my calculator at the end. I'm not going to use it multiple times because this leads to problems. Now, one of the properties we know is called the power property. That means this k right here can be moved out front as a coefficient. This would be k log of 18 is equal to log of 26.3. Now, on the left side, that's k times log of 18. Now, this log of 18 is a number, all right? Not 18, it's log 18, which means if we're trying to get k by itself, and these are being multiplied here, you can divide both sides by log of 18. So what you're going to plug into your calculator now is you're going to plug in log 26.3 over log 18. And if you do that correctly, ladies and gentlemen, we're going to 10,000. So that's 1, 2, 3, 4 spots. You should end up with K is approximately 1.1312. And that's what you should get out of your calculator. Now, pause the video and see if you can get that. If you can't, try and figure out again or ask me for help. I would love to help. You're going to do the same thing on number 10. All right, on number 10, you're going to start by taking the number to the variables by itself. So we're going to take log of each side. So log 16 to the p is equal to log 25. Now, that p has to come out front. When you do that, it's p times log of 16 equals log of 25. So now, since these are being multiplied on the left side, what you're going to do is you're going to divide both sides by log of 16. And so what you're going to plug into your calculator is this. You're going to plug in log of 25 over log of 16. And that'll get you approximately 1.161 for number 10. And that's what p is going to equal. All right. Now, the only difference on number 11 and 12 are the numbers. So try 11 and 12 on your own, and then follow along. So moving down here to the bottom now, there's an extra little hiccup, if you will, in these problems. So let me start with number 13. I'll start with number 13, and then I'll take care of number 16, because number 16 is kind of, well, maybe I'll do both 15 and 16. I'm skipping 14 for sure. So I'm going to subtract 8 from each side. That gives me 14 to the n is equal to, I believe that's 44. Now what I've just done is I've gotten the number to the variable by itself. So now at this point, at this step, I have to take log of each side. So log of 14 to the n is equal to log of 44. Now, I have to take this power, bump it out front. So the n log of 14 equals log of 44. Then I'm trying to get n by itself since those are being multiplied, just like multiplying. It's literally just like having 2n equals 8. We divide both sides by 2. Since these two are being multiplied, we're dividing both sides by log of 14. Not 14, but log of 14. It's a different number. So then we end up with n is equal to log 44 over log 14, which is going to be approximately, and we're talking number 13 here, 1.4339, because we're going 4 decimal places there. So that'll be your approximate answer for number 13. Now I'm going to clear all this stuff off, so if you need to pause right now, because there it goes. Now, let me see if I can zoom in a little bit here, give myself a little bit more room. Ooh, that looks better. Looks a lot better. All right, I like that. Okay, so now let's get into it. The first thing we need to do is get this by itself. So I'm going to go ahead and subtract 4 from each side. When you do this, and these have a little extra step in them, you're going to be fine, I promise. So it'll be 6 to the negative 3.6n is equal to 52. Now we're going to take log of both sides. Okay, it's going to be all right. It'll be log of 6 to the negative 3.6n is equal to log of 52. One step at a time. Even color coding it for you. It's going to be fine. Now, bringing this exponent out front. So it'll be negative 3.6n times log of 6 is equal to log of 52. Great, grand, wonderful. Now, at this point, ladies and gentlemen, we have those two things along with n on this side. So what I'm going to do is I'm going to try and divide both sides by everything I don't need, which is negative 3.6 log of 6. Now, depending on your calculator, you're going to have to plug that in a couple different ways. So hopefully, I might even add that to the calculator video just to make sure you know what you're doing. But anyway, n is going to equal, and this is what I would do. I would do log 52 divided by negative 3.6 log 6. Now, for some of you, that's going to be difficult to plug into your calculators, but others, it'll be fine. Either way, the approximate answer that you should get, and you got to get close to this, is negative 0.6126. That's the approximate answer that you should end up with. Okay? Now, on number 16, the first thing we have to do here is divide both sides by negative 3. We get 12 to the x plus 8 is equal to negative 70. Sorry, well, that's not right. It can't be negative 70. You should divide it by 3. So 71 divided by 3. It doesn't come out evenly, does it? Hang on. Pause. Yeah, so it doesn't come out evenly, so just maybe leave it as a fraction. 71 over 3. Because now we still have to take log of both sides. So it'd be log of 12 to the x plus 8 is equal to log of 71 over 3. Fine. Well, good. Now, after that, I have to take this exponent, move it out front. Now, the exponent is still x plus 8, so I'm putting it in parentheses. This would be log of 12 and then log of still 71 over 3. So I'm going to divide both sides by log of 12. Okay, so that's x plus 8 is equal to, all that in red, log 71 over 3 over log 12. And then to get x by itself, we have to subtract 8 from both sides. So what you're going to do on this one is you're going to type this into your calculator. Log 71 over 3. You're going to take that number, divide it by log of 12, hit enter, subtract 8 from it, and you should end up with approximately, and this is x equals, 1.1272. Okay, and that's exactly what you're going to end up with. Or something, oh, sorry, that's wrong. That's wrong. It's not that one, I promise. It's going to be approximately negative 6.7267. Gotta make sure of that one. Sorry about that, guys. All right, thank you for watching the long video. I understand. Just finish the rest on your own.